So I'm out here at my condenser just messing around, and I have this fancier type meter which does a lot of things some of your more high quality meters. I know like the Redfish meter does a lot of these things, but some of your higher end fluke meters do as well. What I'm doing and what I'm measuring and messing around with is on the electrical side of it, the more the hidden stuff. So what I'm doing right now is just taking different readings. You can see that it's saying that my compressor is 2.49 horsepower. I am drawing 1.85 kilowatts. So I have, you see where it says lag, and this is 0.998 PF power factor. So in essence, what does that mean? If you don't know what it means, I'll be happy to explain what I know, and I'm definitely not trying to say I am some kind of genius at this stuff, but I do a lot of reading and I do enjoy learning. So lag, right? What does that mean? Well, on inductive loads, and yes, that is the frame rate, inductive loads being the condenser fan and the compressor are inductive loads, inductive motors. What does lag mean? That means that the current is lagging behind the voltage. Now, if we were to go on the capacitor, which capacitance, that would be leading. The current is leading the voltage. Because I am on an inductive machine, I am lagging. And that power factor number right there is pretty blasted good. They call it unity, or aka a perfect power factor would be 1. And in simple terms, what does that mean? That means that the current and the voltage are basically peaking and dropping, so positive, negative side of the zero crossing on a sinusoidal sine wave at the same time. And I have another way to show that too, that it is pretty blasted close. So I have 0.19 kVAR, that's kilovolts amps reactive. Now here comes the next screen. So, lagging again. This is my phase angle. See, there's the degree sign. So what does this 2.2 mean? That means my current is lagging my voltage by only 2.2 degrees. Well, 2.4, but it's very close together, which again goes back to if you had a perfect power factor, which is 1, they call it unity, your voltage and current are peaking and falling at the same time, and that would be at 0. And you can see it, and it is going to fluctuate, but the fact that it is, less than 3 degrees is pretty blasted good, which goes back to where my power factor rating is. 244. Oh, well, I went a little fast there, but you can see. It's saying I have almost a perfect power factor. Now, granted, I mean, this is just a meter and not like a power quality analyzer, so I understand there's going to be probably some fudge factor, and I'm not going to take that reading as the cold, hard, indisputable truth. I would probably need a tool that cost, $10,000 to be in that kind of range, but it's close enough. Nah, I still got to do a little bit more reading and a little bit more understanding of that, but I'm getting there, so I'm not going to sprout my mouth off and talk out of my rear end here when I don't have a good, clear understanding of it. But, I mean, to me, this is a good sign. I'm okay with it being lagging. It's an inductive load. But the fact that the degrees are so small means if you can imagine a sinusoidal wave where your voltage is doing this, your current is also doing that, but my current is lagging 2 degrees behind my voltage. Now, if I were to go on this capacitor over here, let's see what happens here. I'm going to go on the hermetic side of the cap. And if you know anything about a capacitor, you know that it is 90 degrees out of phase. So imagine, right? This is just single phase, or what they call split phase, right? L1, L2. They are 180 degrees out of phase. Your capacitor comes in at 90 degrees, which puts it 90 degrees out of one phase, 90 degrees out of the other phase. And the capacitor also helps with improving the power factor. So when you have an inductive load and you have capacitive, or I believe they call it inductive reactance and capacitive reactance, the closer you can get to a power factor of 1, the more you're using the power that you're drawing. Good analogy that I came across would be Engineering Mindset. He has some really great videos on this sort of stuff, and I love his analogy on this. And it basically goes like, you go to a bar, you order a glass of beer. You know, they're pouring your beer from the draft, straight out of the tap, and you get the foam head at the top. Well, you paid for the entire glass of beer. The foam part is basically unusable, and the beer is what you're, how do I say it? What you're using, but you paid for the whole glass. The less foam and more beer in your glass, the more efficient it is. And I could be saying some of this wrong, and if I am, I apologize, and please, by all means, correct me. I am no means trying to constitute myself as a know-it-all, or, you know, like smarter than everyone else. I just enjoy learning, enjoy reading, and trying to learn. I've always been one of those guys who I like to know the what, why, and how of it all. Does it mean it's going to make me a better technician? Possibly. Really don't care. I just do it for my own simple, you know, well-being, because that's what I want to do. It doesn't mean you have to do this stuff, but I will say some of this stuff right here can get you out of a jam, or at the least it makes you a more knowledgeable tech, and the more you know, the more you're worth. You could be a money-driven guy, and that's fine. Well, learn more, you get paid more. And obviously the horsepower thing's not going to be accurate because I'm still hooked up to the capacitor, but let's go back here. I mean, overall, I'd say that my little system here is is being pretty blasted efficient. I am using most of the current and power that I am drawing, and that's a good thing. Means I'm getting more bang for my buck, basically, miles per gallon type stuff. Anyways, I hope you enjoyed this video. I'm sure I was wrong in some of the stuff I said, and I do apologize for that, and am more than welcome to listen to constructive criticism. There's always somebody out there who's more knowledgeable and more smart, and thank God that there is, because we should all try to hope and be better at what we do. And yeah, this is kind of my little Franken system here. And I put it on a previous video. These are my high pressure, low pressure switch. Any of those go out, I know that that particular one has tripped, and you know, I got my little ICM fan speed controller. And yeah, I'm a tinkerer. I love to tinker around with stuff, and I don't know, I enjoy what I do for a living, and I hope you do too. Hope you're all having a great day, and happy HVACing.